Hello student, previous class we discussed about the atomic mass, what is atomic mass and what are the different method for the calculation of atomic mass. At first I used the formula atomic mass is equal to equivalent mass into valency. This is the first formula. Second I applied atomic mass is equal to 2 into vapor density divided by atomicity. In this class, we have done some problems related about these two methods. In this class, I will explain about the third method, that is your Dulong Pettis method. As per the Dulong Pettis method, uh, we can say that the product of atomic mass and specific heat of a solid element is approximately equal to 6.4. This is the mathematical equation you can write here. Approximate atomic mass is equal to 6.4 divided by specific heat. The Dulong Pettis method is only applicable to the solid element except the beryllium, boron, carbon, and silicon. That means for the calculation of the approximate atomic mass by using Dulong Pettis method is not possible for the solid element like beryllium, boron, carbon, and silicon. Here you can say that what is specific heat. Before define the specific heat, you can take an example. Suppose 1 gram of a substance is given, of a X substance is given. The substance is must be a solid element. Then suppose the temperature is your 20 degrees centigrade. For increase of the temperature, generally we supply some heat to the X substance. After supply of the heat to the X substance, the temperature suppose increase to 21 degree centigrade. Here you can say that the supplied amount of heat. Suppose the supply amount of heat is your Y. Then here you can say that Y is the specific heat. So here we can define the specific heat is the amount of heat per unit mass required to raise the temperature by 1 degree Celsius. That means for increase of temperature by 1 degree Celsius of a unit mass of a solid element, what amount of heat is given to the element, that is called specific heat. By using this formula, that is your approximate atomic mass is equal to 6.4 divided by specific heat, you can able to solve many problems. Take problem number 1. The equivalent mass of a metal is 5.3 and its specific heat is 0.401. Calculate the atomic mass and valency of the metal. Here what will happens, equivalent mass is given and specific heat is given. By using the Dulong Pettis method, here I can write approximate atomic mass is equal to 6.4 divided by specific heat. Now put the value of specific heat. This is the value of specific heat, that is your 0.401. So here I can write approximate atomic mass is equal to 6.4 divided by 0.401 for 0.401. That means after calculation you can find approximate atomic mass is equal to 15.96. Look at that, here the atomic mass is said to be approximate atomic mass, but we need the exact atomic mass. Here the equivalent mass is given, that is your 5.33. Again apply the same formula but in different way. Here you can find the approximate valency by using the approximate atomic mass. Here you can write approximate valency is equal to approximate atomic mass divided by equivalent mass. Now put the approximate atomic mass, that is your 15.96 in this formula, and also put the equivalent mass in this formula. So here you can write approximate valency is equal to 15.96 divided by 5.33. After calculation, after solving, you can find approximate valency is 2.99. But remember, the valency is always a whole number. 2.99 is not possible, so it is converted into the nearest whole number, that is your 3. So here you can write exact valency, that is your equal to 3. We know that again apply the same formula, but use the exact valency and the equivalent mass. Here you can write exact atomic mass is equal to equivalent mass into valency. Now put the equivalent mass. This is the equivalent mass, that is your 5.33, and put the exact valency, that is your 3. So here you can write exact atomic mass is equal to equivalent mass into valency is equal to 5.33 into 3. After calculation, the value is your 15.99, which is also nearly equal to 16. So here I can say I can write like that. Therefore, the atomic mass is 16 AMU, and the valency is your what? And the valency is your 3. Take another problem. This is the second problem. On the specific heat, here the specific heat of a metal is given, and the specific heat is 0.25, and its equivalent mass is 12. What is its correct atomic mass? Mention the formula of its chloride. In some problems, what will happens, the equivalent mass, the data for the calculation of equivalent mass is given. In that case, you will apply the different formula for the calculation of equivalent mass. By using the data, you can find out the equivalent mass. After molecular mass, I will teach you about the equivalent mass. For this problem here, the equivalent mass is directly given, so there is no need of application of the different method for the calculation of equivalent mass. But remember, sometimes question also arises. Only the data is given for the calculation of equivalent mass. Here, at first, you will calculate the equivalent mass by using the data. In this problem, the specific heat is 0.25. So, in the first step, calculate the approximate atomic mass. Now, put the specific heat value in this formula. That is your Dulong Petit's method formula. Here, you can say that approximate atomic mass is equal to 6.4 divided by specific heat equal to 6.4 divided by 0.25. After calculation, it is seen that the approximate atomic mass is equal to 25.6. Here the equivalent mass is given 12. Like the problem number 1, you can solve the problem number 2. Again apply the same formula. Approximate valency is equal to approximate atomic mass divided by equivalent mass. Here the approximate atomic mass is your 25.6, and equivalent mass is your 12. So I can write here approximate valency is equal to approximate atomic mass divided by equivalent mass is equal to 25.6 divided by 12. After calculation, it is seen that the value is your 2.133. The valency cannot be fraction, it is a whole number. So 2.13 is converted to into the nearest whole number, that is your 2. So here I can say that the exact valency is equal to 2. Again apply the same formula for the calculation of the exact atomic mass. Here you can write exact atomic mass is equal to equivalent mass into valency. Now put the equivalent mass value and put the value of exact valency. So here you can write exact atomic mass is equal to equivalent mass into valency is equal to 12 into 2, that is equal to 24. Therefore, the atomic mass is your 24 AMU and the valency is your 2. Look at that. In this question, another question also written, mention the formula of its chloride. Chloride means your metal is present, your chlorine is given, that is your chloride is given. So obviously, obviously your target is to write the molecular formula of a metal chloride. For writing the formula, you need the valency. Here you can know that the valency of the metal is your 2, and the valency of the chlorine is your 1, you know very well. Now crisscross this like that. After that you will write like that MCl2. So here the correct formula for the metal chloride is your MCl2, M for metal. For solving such type of problem by using Dulong-Petit's method, uh, you can follow a general step. First step is the find the approximate atomic mass by using the Dulong-Petit's method. After getting the approximate atomic mass, you can find the approximate valency by using the equivalent mass and approximate atomic mass. After getting the approximate valency, in the second step, after getting the approximate valency, convert the approximate valency to the exact valency. In step number, again apply the same formula but in different way. That is your in step number 3, again apply the formula exact atomic mass equal to equivalent mass into valency. Now put the value of equivalent mass and the exact valency. After putting the equivalent mass and valency, you can calculate the exact atomic mass. So this is the common way to solve the problems by Dulong-Petit's method. This is all about the Dulong-Petit's method. Thank you very much.